Bismillah ar-Rahman ar-Rahim. We'll continue. The last things we did was this one. So we'll continue doing the next example, which is this one, cosine x over 2 plus sine x. Okay. We'll do the same thing. Domain will be what? This thing cannot be not always not equal to 0, so domain all real numbers. Okay. Intercepts. I have y-intercept. We'll make x equal 0. You'll get what? Y equal 1 over 2 plus 0, which is half. So you have 0 and half. That's the y-intercept. X-intercept. All right. We need to be careful before we continue. I need to check, is this a periodic function? Is this periodic function? Is f of x which means f of x plus b equal f of x. Okay. I notice I know cosine x. I know cosine x plus 2 pi equals cosine x, and sine x plus 2 pi equals sine x. So we'll check f of x plus 2 pi. That will be what? Cosine x plus 2 pi over 2 plus sine x plus 2 pi. And that will be cosine x over 2 plus sine x, which is what? F of x. That means what? F is periodic function with period 2 pi. Okay. That means what? That means instead of dealing with the function from minus infinity to infinity, since the function, the domain is R, I can deal with just a specific period. I will take 0 to 2 pi. The rest is just a copy. So I need to copy, and so on, like sine x. Sine x, if you graph it between 0 to 2 pi, now you can just repeat that things. So I'll work out this function. I'll work out this function from 0 to 2 pi. And you know, my graph will be just a copy of this period or of this interval. Okay. So that means here, when cosine x equals 0, I know x equal pi over 2 and 3 pi over 2. I will work only between 0 to 2 pi. Or otherwise, I have infinitely many points. Okay. Symmetry, no symmetry. Symmetry, none. None. Asymptotes, also none. The function is, cannot have an asymptote. The denominator cannot be equal to 0, and the numerator is bounded, so it cannot have. Okay, what else? Domain, intercepts, periodic, no symmetry, asymptotes. No, we'll do f prime. Okay, now we'll do f prime. F prime will be what? Yeah, by the way, in all of these examples, I will get the f prime. Yeah, I will not do the calculations in this recording, huh? So just I will give you f prime, which will be my 2 plus 1 over 2 plus sine x square. you know, this is the quotient rule. You need to do the calculations. Just to save time, I will consider we did f prime. So now this one cannot be 0, so we have nothing to worry about. So I have f prime equal to 0. That implies sine x equal minus half. So I have x equal, with sine x equal minus half. Third and fourth quadrant, and my reference angle is pi over 6. So it will be 7 pi over 6, or x equal 11 pi over 6. So I'll put the signs. As we said, we deal only from 0 to 2 pi. I have 7 pi over 6, and I have 11 pi over 6. Check the signs. Between 0 and 7 pi over 6, I'm checking what? I'm checking this function. Don't forget the minus sign. Don't forget the minus sign. Okay. Between 0 and 7 pi over 6, I'll take a point like what? Pi, for example, which is 6 pi over 6. Pi, sine pi is 0, so I have minus 1, so that will be negative. Okay. Now, I'll take a value between 7 pi over 6 and 11 pi over 6. I will take what? 3 pi over 2. Sine 3 pi over 2 is minus 1. So that will be minus 2 plus 1. Minus, that will be plus. Here, one way to check it, I have this is 360. This is 11 pi over 6. I know pi over 6 is 30. That's 330. So if we take a value, it will be, I know that sine 360 is 0 and sine 330 is minus half. So it will be a value between minus half and 0. Yeah, negative 1. So that will give me minus. Because this will be, it means 2 sine x plus 1 will be a positive value. If you take a value between minus 1 and 0, take minus 1 over 4, it will give you what? Minus half plus 1. This is positive times minus, it will be negative. So it's decreasing, increasing, decreasing. Okay. And we have local minimum here, a local maximum here. Okay. Now we'll go to f double prime. As I said, we'll do the calculation, not in this recording. So consider I did f double prime. I'm getting what? I'm getting f double prime will be minus 2 cosine x times 1 minus sine x over 2 plus sine x cubed. Okay. Now, check the signs. I need cosine f double prime equals 0. Implies in cosine x equals 0 or sine x equal 1, which implies what are my x values? Will be 0, 0, yeah, which is, yeah, or not consent, because this is will be the end point, okay? 0, not 0. What is this? It will be pi over 2 and 3 pi over 2. And sine x equal 1 means pi over 2. So it's there. خلاص. So I will put pi over 2 and 3 pi over 2. Between 0 and 2 pi. And I will put pi over 2 and 3 pi over 2. Which is easy to check now. Which is now quadrant. Huh? So check take pi over 4, that will be positive 1 minus square root 2 over 2, which is positive also, times negative over positive, that will be negative. Okay, between 3 pi over 2 and 3 pi over 2, take pi, sine pi is 0, cosine pi is minus 1, so that will be positive. Sine pi will be 0, that will be positive. The numerator is positive and the denominator is positive. Between 3 pi over 2 and 2 pi, or take what? Yeah, 7 pi over 4. But cosine is positive, sine is negative, so that will be positive. Positive times negative over, yeah, this is for sure less than 2. So that will be negative. So it's concave down, concave up, concave down. Okay. Now we'll put all of these things in one graph, in one test intervals, or real line, only between 0 to 2 pi. So the ones which I am looking for are pi over 2 and 7 pi over 6 and 3 pi over 2 and 11 pi over 6 also. Okay. Decreasing all the way until 7 pi over 6. Then it will increase until 11 pi over 6. Then it will decrease again. And it's concave down here, concave up, and then concave down, concave down. Okay, want to grab the function now. Okay, I know at 0 it's half. This will be half. I know intercept pi over 2 and 3 pi over 2. Okay, I'm working only until 2 pi, huh? I'm doing it until 2 pi only. Okay. Where at 2 pi, I'm getting what? Doing the same thing. 1 over, where at 2 pi, I'm getting half also. So this is half. At 2 pi. Okay. Okay. Between 0 and pi over 2, is doing what? Decreasing and concave down. It's decreasing, for sure it will start to this, but concave down. Concave down, something like this. It will do something like this. But it's concave down and decreasing. Between pi over 2 and 3 pi over 2, notice until 7 pi over 6. So I need to check f 7 pi over 6. F 7 pi over 6. That will be what? Cosine is minus square root 3 over 2. And that will be 2 plus or minus, because pi over 7 pi over 6 in the third quadrant is negative. That gives me what? 3 over 2 minus square root 3 over 3. So it will be somewhere here. That's minus square root 3 over 3. That is 7 pi over 6. Where the function is going down, but it's concave up, huh? Concave up to do something like this. Okay. At between 7 pi over 6 and 3 pi over 2, it will be increasing and concave up. Something like this. Now it comes to 11 pi over 6 also. 11 pi over 6 is an important point to check. Where it will be square root 3 over 3. That will be square root 3 over 3. Can I check which one bigger? Square root 3 over 3? By this trick, multiply 2 by 2. So instead I'll check, multiply this one by 2 to 2 square root of 3. Yeah. Okay. So to check which one is bigger, square root 3 over 3 or half, I'll do this trick, multiply by 2, this one, 2 and 2, both numerator and denominator to have 2 square root of 3 over 6 and 3 over 6. And I know square root of 3 is 1.7. So this is 1.7. So 2 times 1.7 will be 3 point something. So this will be bigger. So this one will be bigger. So this one will be here somewhere. Okay. And the function will do what? It will be concave down, but increasing. So it will do something like this. Concave down, but increasing. And then it will decreasing and concave down. It will do something like this. Well, this is the 2 pi. Okay. Now what will happen? After that, it's just a copy. So these things, I'll copy it here, I'll copy it everywhere, copy it there, copy it everywhere. That's it. So this is the graph of the function. Now, do we have local maximum, local minimum? Yes. Also, we have an absolute maximum here. We have absolute maximum, which is equal to 3 over 3. And also, I have an absolute minimum, which is minus equal to 3 over 3. That will help us also to find the range. Because this will be the largest value, and this will be the smallest value. So the range, minus square root 3 over 3, up to square root 3 over 3. Okay. So yeah. Actually, I can find the absolute maximum, absolute minimum, since I define it only on a closed interval. This one function is continuous, so I can do this also. Okay, let me do this function. What's the domain here? I have 4 minus x squared should be greater than 0. We solve this. That means x squared less than 4. That means x is between minus, we can do it into a step. I'm sorry, 12x less than 2. That means x between minus 2 and 2. Okay, so I'll work only in this interval between minus 2 and 2. Other than that, the function is not defined. Intercepts. Okay. Y-intercept, I'll make x equal 0. I'm getting y equal ln 4. So I have 0 and ln 4. Okay. X-intercept, will make y equal 0. So I have ln 4 minus x squared equals 0. So take E, that 4 minus x squared is equal to 1. That means x squared equal what? Square root of 3. That means x equal plus or minus square root of 3. And those belongs to the domain. Square root of 3 is less than 2. And minus square root of 3. Okay. Greater than minus 2. Okay. Now, symmetry, very clear, f of minus x is equal to f of x. So it's symmetric with respect to the y-axis. So I just graph one part, the other part will come. Asymptotes. We don't have horizontal asymptotes because the function x cannot go to infinity or minus infinity. Actually, x is bounded between -2 and 2. So there is no horizontal asymptotes. Since we cannot discuss the function as it goes to infinity or x goes to minus infinity. Vertical asymptotes, I can check at 2 and -2. For sure there is, yeah, because it will be in 0, it goes to minus infinity. So if I check at 2, for the vertical asymptote, I know limit is goes to 2 from right, 2 from left. Yeah, because 2 from right will give me a value more than 4, so it will be a negative. So just 2 from left, that will give me minus infinity. And limit x goes to -2 from right, this side, of f of x, also I'm getting minus infinity. Okay, so I have vertical asymptotes, x equal 2 and x equal -2. Great. Now we'll do f prime. As I did before, I'm giving you f prime. That will be -2x over 4 minus x squared. So check f prime equals 0. I'm getting x equals 0. Okay. So check the 0. I know this is -2 and this is 2. Take a value between -2 and 0, -1, that will be positive. 1, it will be negative. So it's decreasing and increasing. It will be increasing and decreasing. So I have 0 is a local max. 0, I have a local max. We'll check f double prime. I'm getting what? F double prime, if we do the calculation, -8 minus 2x squared over 4 minus x squared squared. If we do the calculations, yeah, no need to waste time and do the calculations. You can do it, but this is the answer. Over 4 minus x squared all squared. Okay. Now, if you notice, this one is always negative. Like any value, x squared will make it positive times -2, negative, with the -8, always negative. It means I have, this is -2 and 2, only my domain is here, and the function is concave down all the way. Okay, now let me graph the function. Now I will graph the function. Combine all of these things to graph the function. The domain -2 to 2, so my constraint only at -2 to 2. Intercept 0 and then 4. Then 4 is where? And then 4 is something here. Then 4. Okay. It's positive. Okay. I have minus square root of 3. I have here minus square root of 3. And here I have square root of 3. Okay. This is -2. And this is 2. These are the asymptotes. Okay. So if combine these two, it means -2 to 0. This is concave down all the way. So it will be increasing, but concave down. So it will do something like this, increasing. This is asymptotes. Both are going to minus infinity. So I go for minus infinity, passing through this point. And from the symmetry side, this will give me this. Well, it's doing the same thing. Okay. So it will be in this, from 0 to 2 in this region. From 0 to 2, it will be decreasing and concave down. So this will be the graph of the function. What is the absolute maximum at x equal ln 4. No, at x equal 0, absolute maximum is ln 4 at x equal 0. No absolute minimum. And the range is from minus infinity up to ln 4 closed. Okay. Yeah. More graphs. Analyze and sketch the graph of this function. X squared minus 2x plus 4 over x minus 2. Okay. Domain. All real numbers except 2. Intercepts. Y-intercept. I will make x equal 0 to get y equal to get y equal 0, 0, minus 2. So I have the point minus 2 and 0. 0 and minus 2, sorry. 0 and minus 2. X-intercept will make y equal 0. I have this x squared minus 2x plus 4. Will that be 0? This one cannot be 0. Why? Because this one is this, which is x minus 1 squared plus 3, which is always positive. So cannot be 0. So there is no x-intercept. Okay. Now we'll do what? Symmetry? No symmetry, because this is even odd, so it will not make any symmetry. Asymptotes, yes. We have vertical asymptotes, x equal to, very clear. And we have horizontal asymptote? No, we don't have horizontal asymptote, but we have what? We have slant asymptote. Yes, we have slant. How to do that? Long division. That will give you x. That will be x squared minus 2x plus minus plus. So that will be 4. So it means my slant asymptote y equal x. Asymptote y equal x. Okay. What else? You will do what? Symmetry, asymptote, intercept, domain. That's it. We did everything now. Okay. Asymptotes. This one, asymptotes. Now we'll do f prime. I don't have it ready, so I will do it now. 2x minus 2 times x minus 2 minus x squared minus 2x plus 4 all over x minus 2 squared. That will give me what? 2x squared minus x squared, that is x squared, minus 2x minus 4x minus 6x plus 2x, so it will be minus 4x, plus 4 minus 4, خلاص مع السلامة. Yeah, plus 4 minus 4, that will be 0 over x minus 2 squared. So that will be x minus 4 over x minus 2 squared. Okay. So it means f prime equals 0. I have x equals 0 or x equals 4. So I will put now these points. I have at 2. It's open. So I have 0 and I have 4. Take values for this one. Take minus 1, negative, times the negative, positive. This is always positive. Huh? So that will be positive. So 0 and 2, take 1, negative. Between 2 and 4, take 3. Still negative. After 4, that will be positive. So that will be increasing, decreasing, decreasing, increasing. So I have local max here. They have local min here. Okay. F double prime. Let me do F double prime. That will be what? Now I'll do it with this one. Be careful. Okay. That will be 2x minus 4 times x minus 2 square minus this, which is x times x minus 4 times 2, x minus 2 over x minus 2 to the power 4. So I will take x minus 2 as a common factor. You notice if I take 2, that will be x minus 2. So I have x minus 2 cubed, that's okay. That will be what? 2 times x minus 2 square. I can take 2 also common factor to save time. I can take 2 also common factor. So I have x minus 2 square, which is x square, x minus 2 square. Let me write it. X minus 2 square. Here I took 2x minus 2, خلاص. Minus x square plus 4x over this, which is will be what? Now this is cancelled with this, remaining 3. I have 2 times what? X squared minus 4x plus 4 minus x squared plus 4x over this. So this is cancelled. All of this cancelled. So I have 8. That gives me 8 over x minus 2 cubed. So I'll be concerned only about 2. And before 2, this is negative, this is positive, so it's concave down, then this is concave. Good. Yeah. If I put it in one graph, I need 0, 2, open. This is 4. But I know it's going up, decreasing, decreasing, increasing. This is concave down, up to 2. This is concave up to infinity. Okay. Now I want to graph the function in one place. I want to graph the function in one place. Okay. Take the value, they have 0 and minus 2. This is the y-intercept, no x-intercept. Okay, I have slant asymptote y equal x. Y equal x is a slant asymptote. Okay. What else? Yeah. Now it comes from 0 to 2. Yeah, from minus infinity to 0. Minus infinity to 0. The function is increasing and concave down. Okay. Take a value to be sure. For example, take f of minus 1 will be what? 1 plus 2 plus 4 over minus 1. That will be minus 7. So the graph will be somewhere here. Minus 1, it will be somewhere here. So the function is increasing, but concave down until 0. So it will be, this is the asymptote also. Will the graph cross the asymptotes? We need to check. F of x, well, this, and I have asymptote y equal x. Will these two intersect? Check. Are they equal to each other? I think no, but let me check. So 4 equals 0, which means wrong. So there is no intersection point. Okay. So the function will do something like this. Oops. Increasing, but concave down until 0. Then it will be what? will be decreasing concave down. At 2, we have an asymptotes, huh? We have at 2 asymptotes. At 2, we have an asymptote. Forget this. Yeah, there is an asymptote at 2, vertical asymptote. So it will be doing like this. Then it will be decreasing and going down. So it will do something like this. Now we want to deal with this side from 2 to 4. I'll take a value like f of 3. F of 3 will be what? 9 minus 6 plus 4 over 1, which is what? 13 minus 6, that will be 7. So it will not be here, it will be somewhere here. So the function is doing what? Decreasing a concave up, it will decrease a concave up, then it will do something, and then increasing until 4, huh? F of 4 will be what? F of 4 will be 16 minus 8 plus 4 over 2. Correct? Yeah. 16 minus 8 plus 20 minus 8, that will be 6. So it will do something at 4. It will be 6 somewhere. So the function will do something like this. It will concave. Then it will concave up from here at 4. Yeah, this is 6. Okay, that will be the graph of the function. Okay, and this is the asymptote, so it will do something like this. Approaching them. Yeah, go near the asymptote. Yeah, that will be the graph. Find the equation of the slant asymptote of this function. How to find the equation of the slant asymptote? We do long division over x plus 1. That will be x. By the way, I can do it this way instead of 0 plus 0x plus 1. So to show there is no coefficient at x. Then divide this by this, I'm getting x multiply, so I have x squared plus x sine, that will be minus x plus 1. I am not done because this is still the same degree as this one. I want it to be less. Minus 6, that will be minus 1, divide, multiply, minus x minus 1, that will be plus, that will be 2. So the slant asymptote will be y equal x minus 1. And what's good about the slant asymptote, also you can check, because we are saying in f of x is this one is x minus 1 plus the remainder over x plus 1. And also these things I can check because I can simplify to be sure it's like this one or not. That will be what? X squared minus 1 plus 2 over x plus 1, which is x plus squared plus 1 over x plus 1, which is this one, which is the same. So this is correct. So this is my sentence. Just I'm checking, huh? Here, I'm just checking. Okay. To do another graph, x cubed over x squared plus 1. I have, yes, I have it. I have everything. Okay. What's the domain of f here? All real numbers. Intercepts. Let me do it quickly. Very clear. X equals 0 implies y equals 0, and y equals 0 implies x equals 0. So f will is 0, 0. Okay. What else? It's an odd function. So f is symmetric with respect to the origin. Asymptotes. Vertical asymptotes, no. Horizontal asymptotes, no. Slant asymptote, yes. How to get it? X cubed over x squared plus 1. It will be x that will be the degree is less. خلاص, so I stop strata asymptote y equal x. Okay. Now we'll do f prime. If you do f prime, this f time, that will be my f prime. X square over x square plus 1 all square, which implies f prime equals 0. I have only x equals 0. So I'll put 0. And before that, it will be positive, positive. So the function is always increasing. Okay, f double prime. If you do f double prime, if you do the calculations, you'll get this. Oh, cubed. That will be cubed. Okay. So f double prime equals 0. Have x equals 0 or x equal plus or minus square root of 3. I'll put minus square root of 3. 0 square root of 3. Take a value to minus square root of 3 minus 2. That will be negative. Negative, that will be positive. Yeah. Take minus 1. That will be negative, but now is here positive, so that will be negative. 1, it will be positive, huh? That's positive times positive. 2, positive times negative, that will be negative. So it's concave up, concave down, concave up, concave down. No need to combine the two because this is always increasing. So nothing to check. Nothing to worry. Okay. Now I want to graph the function. Can we find the range here? I'll go back to this one, but let me graph the function here. I know this is, yeah, by the way, the asymptotes, will it be crossed or not? I have y equal x cubed over x squared plus 1, and the asymptote y equal x. Will these be equal to each other? Is there a point of intersection? I have x cubed equal x cubed plus x. So I have x equals 0. So yes, and it will strict about this. So I have this is the asymptote, and this is a point in the graph. Okay. Now what else I have? Symmetric about the origin. So I graph only one part, or one side, the other side will come. Between minus of 8 to minus square root of 3, I can check f of minus square root of 3. It will be what? Minus 3 square root of 3 over 4, which is greater than minus square root of 3. Yeah, so minus square root of 3, if I have it here, the value should be somewhere here. That's minus 3 square root of 3 over 4. Okay. So the function before that, it will be all of this increasing, but it will be concave up. So it will do something like this until here. Then it will change to concave down. Concave down until 0. And now it's a copy about the origin, just a reflection about the origin. So it will be concave up and increasing. That will be concave up, increasing up to the same with square root of 3. That will be 3 square root of 3 over 4. Then it will concave down and go beside the intercept, beside the strata asymptote. What's the range here? Is there absolute maximum, absolute minimum? No absolute maximum, absolute minimum. And the range is from minus infinity to infinity. And take all the values of there's no steps. Okay, let me go back to this one. Is there absolute max, absolute minimum? No, no absolute maximum, no absolute minimum. No absolute maximum, no absolute minimum. Okay. And the range is, it's from minus infinity up to -2, from minus infinity. This is -2, correct? Huh? At x, yeah, up to -2 union. This one, when it's at 4, I have 6 here, because this is the local minimum, right? Yeah, it's a local minimum, so it will be 6 to infinity. That will be the range. Okay. Let me do this asymptotic equation, and then I will stop. Yeah, 61, easy ones, huh? X squared plus 1 over x plus 1. X, I have x squared plus x. Change the sign, so I have -1. So I'm getting 2. So the asymptote y equal x minus 1. Okay, 63. Do this over. That will be 2x. So I have 2x cubed minus 2x squared plus 4x. Change the sign. That will be minus plus minus. Add them. I have minus 3x squared minus x. That will not make a difference. It's okay. Minus 3x squared over x squared. That will be minus 3. Multiply minus 3x squared plus 3x plus 6 plus 9. Okay. 65 x squared over x minus 1. That will be x. Multiply. I'm getting x squared minus x. Change the sign. That will be plus x. Are we done? No. Divide again, plus 1. So I have x minus 1 minus plus, that will be 1. So my Srati asymptote, x plus 1. Last one, which is actually easy one. This one I can do it right away. That will be x cubed over x squared plus 4 over x squared. That x plus 4 over x squared. Which is if I do the long division, I'm getting the same thing. So very clear, y equal x is my slant asymptote. These are the answers. Okay. I'll stop the recording. Thank you.